So today we have this lecture on object detection, and I will say like this is the most interesting lecture you will see in deep learning during this course. And we have already seen like how you can do classification. That might be like maybe might have been too much challenging for you, but if you have understood that really well, then I think moving from classification to detection in itself, it seems like a big deal because it's like it's not just like sample level prediction. You have to localize that prediction as well, like where exactly that's happening in your images. So that seems like complicated, but today you will see like really it's not. It's like you can solve this task even with like a very small change to your the way you are doing classification. And we are going to cover like some advanced algorithms to do that, some of the like state of the art algorithms. And you will see that like how simple the ideas are there, how intuitive they are. And so it's encouraging because if you can understand like how object detection is done, you already know how classification is done. Then in a way, we are kind of covering like the full landscape which you need. And I think most of the problems which you will have in computer vision, you can just use these ideas, extend these ideas, and solve those problems. So you'll be, I think, will be more confident. All right. So the agenda for this lecture is we'll briefly cover the basics of object detection, what object detection is, and how it's different from image classification. And we'll start with a very simple solution. We have talked about that earlier in the course as well. So we'll look into sliding window approach. And then we will briefly cover how we evaluate any object detection algorithm. That's actually a very important topic. Followed by that, we'll have CNN-based approaches, and we will go through like a series of algorithms, and all of them are kind of related. So we'll start with like the basic CNN solution you can have, and then series of 3 algorithms which are based on this region proposal network. Okay, so let's start with the basics of object detection. So before we start, like let me give you some nice results which we can actually get today using these deep learning algorithms. So I'm showing you a video which is like completely like you can say it's a surveillance video, and it's streamlined, and this is like a state of the art algorithm. This is not like what we are going to discuss, but again, one of this state of the art algorithm which can perform object detection in images. So what's being done is you take that algorithm, you have this video feed, you perform object detection on every incoming frame, and then that will give you those detections, those bounding boxes over there, right? And then we have a very simple algorithm which actually connect these bounding boxes across frames. And once you have that, you can actually track these objects. So you can say like this is, you can see like kind of near perfect, right? It's not missing any object. It's able to track them. It can differentiate between trucks and cars. Sometimes it's getting confused. Okay, but these are really impressive results. And I think the algorithm which we are going to discuss today, if you can develop those, you will be able to get these kind of results as well. So let's try to understand what object detection is. So we have seen object recognition already, right? And the idea is given an image, you have to say which class it belongs to. And we have seen these images earlier as well. So if you are doing object recognition, let's say your class is person recognition, you just need like a binary classifier saying whether a person is present or not. Okay, we have seen like a lot of variations of this problem throughout this course. Now, as we move from classification to detection, the only change you have is given an image, you will still say whether that object is present or not. And you need like one more prediction which you can use to draw this kind of bounding box on this image. Okay, so that's the localization, and that makes it like the detection problem. And for this, there are a lot of variations which you can use. One simple variation could be for this bounding box, you only need 4 different numbers. Okay, so for classification, you just need one number. It could be between 0 and 1, the probability of that object being present. For detection, you need 4 additional numbers. So those numbers could be, for example, the left top coordinate of this bounding box, and then the top right, or you can select the bottom right coordinate. So it will be like x1, y1, and this could be x2, y2. If you have those 4 numbers, you can easily draw this bounding box. Okay, so that's one variation. The other interesting variation could be you can say that, okay, you need the center of this bounding box, again, X and Y, two numbers. And then you need like, what's the width of this bounding box? What's the height of this bounding box? Again, four numbers. You can again draw the bounding box over the image. And there can be like other variations if you want to think about that. Now, again, same as object classification or image classification, you can have different variations and in this problem as well. For example, even in human detection, there might be different different variations, the problem, the way you want to formalize your problem. For example, you might have aerial images, right? Or some kind of oblique view. So in that case, even this is person detection, but the problem is quite different from when you're solving the same problem from ground view. Even for the human, you can see like the perspective is changing a lot. Okay, the objects are far away. And you can have like surveillance images or videos like this. So you can see like even the problem is same, but you might have like different kind of challenges in these two scenarios. Now, similar to object classification, where you might have multiple objects present in the image, then you need multiple heads for the prediction, right? We saw all those variations there. Similarly, you can have multiple objects for detection as well. For example, in this image, I think we have seen this image before in the class. You might have all these object categories, and then the problem will transform into like, you will say like whether bottle is present or not, whether laptop is present or not. So you will have those classification predictions. And in addition to that, for each instance of that class, for example, bottle, you need four numbers, which you can use to draw this bounding box. So you need like those bounding box predictions for all the classes or all the objects. But it's a little trickier than that because you might have multiple bottles, right? In this case, I can at least see like these three bottles here. So it's not just saying that bottle is present. You have to say that 1, 2, and 3 bottles are present. And for each bottle, you need these bounding boxes. So it's slightly complicated. Okay. And we will talk about like all those, how that can be addressed. And I mean, we have given the motivation like why we need object detection, but this is like very simple example. Let's say if you have a self-driving car, in that case, the object classification is not going to solve your problem. Okay, you need like much more stronger than that. So it could be like detection is much better than classification, because what's happening in self-driving car is when the car is driving on the road, then it doesn't matter whether algorithm can say that dog is present or not, because dog might be just like in the nearby park, right, which is visible like from the car's range. But the important is like where exactly the dog is located. If a pedestrian is crossing the road, we need to know like what's the location of that person. If the person is on the road, then the algorithm need to decide, we'll have to put on brakes, right? And in comparison to classification, if it just say, okay, person is present, that's not going to help you out because person could be anywhere.